solving polynomial equations and functions. So we're taking a look at solving these polynomial equations and functions. The first thing that we're going to do here is talk about the principle of zero products. Okay. The principle of zero products. The principle of zero products tells us that if we have A times B equals 0, then we really get an equation of A equals 0 and B equals 0. All right, so if we have some equation where A times B equals 0, then all this really means is that A equals 0 and B equals 0. Right, so it's really nice because what we can do is we can solve equations in this form. Right, we can solve equations in this form. Right, example. Solve. Let's take a look. If there's some already now. Here we go. Solve x plus 2, x plus 3 equals 0. Right. So notice that this is in the form of that principle of zero products. Right. What this really means, x plus 2 equals 0, and it means x plus 3 equals 0. And we can solve each one of these. Right, should be very nice, right? We subtract 2 to both sides. We get x equal -2. Right, we subtract 3 to both sides. We get x equal -3. So you get answers of -2 and -3 there. Any questions with that example? Does anyone need another minute copying that down? Example B, t open parentheses, 5t minus 4 equals 0. Well, same thing. That means t equals 0. That means 5t minus 4 equals 0. Right, this one is already done. That t equals 0 is already done there. We don't have to do any work with that one. All we have to do is solve the other one. Right, so this is done. T equals 0 is done. So now just work on the right side. 5t minus 4 equals 0. Go ahead and solve there. All right, so it should be a nice, easy problem. We just add 4 add 4, get 5t to equal 4 divided by 5 divided by 5. We get an answer of 0 and 4 over 5. Any questions here, y'all? Any questions? So these examples are really nice because once again, they're set equal to 0, right? But something that's very important to note, right, is if an equation is not equal to 0, then first thing you do is set it equal to 0. Second thing you do then is factor it. And the third thing you do now is use the principle of zero products property. Let's see if I can get it. All right, so use the principle of zero products property, and that is what your homework will look like. Keep in mind that you need to know how to factor now, right? So hopefully everyone has practiced factoring, knows how to do it extremely well. So we'll take a look at a few examples here, okay? Does anyone need another minute copying this down? X squared minus x equals 6. Notice that this equation does not equal 0, so what do you have to do first? What do we do in order to make it equal 0?
You move the 6 and you equal it to 0.
Very good, right? Move the 6 to the other side, right? So I'll rewrite the problem here, right? We subtract 6, giving us x squared minus x minus 6 equals 0. Now from here, we should be able to factor this. Should be a very easy problem here. Leading coefficient is 1. So it's the product of negative 6. That gives us negative 1. It should be nice and easy there. That's what, negative 3 and 2, if I'm not mistaken. All right, that should work out. So now you can show it in the factored form, x minus 3, x plus 2 equals 0. And now from there, you can go ahead and set each one equal to 0. Adding 3, get 3 over here, subtract 2, you get negative 2. Giving us answers of 3 and 2. Should be a nice, really easy example. I mean, I think this is a really nice one because it's a trinomial with 8 equals 1. This would be a nice problem to put on the test because this covers 4.4. So I won't put a problem on 4.4 on the test, but I'll probably put something like this because it covers that section. Any questions here, y'all, with this first example? Anyone
Yeah,
wanna-
how'd you get -6 and -1?
How did I get from -6 right there, -1 right there?
So you just multiply A and B?
No, A is 1. This is A. A
Okay.
is 1. Right, like the AC method. You do A times C. 1 times -6 is -6.
But you just do B and C.
Correct, because of the fact that this is a trinomial and A equals 1, which is not going to be the case for the next example. But yeah, when it's a trinomial and A equals 1, it's nice and easy. Just like this one. Very good.
Okay.
Other questions? All right, next example. B is 7y plus 3y squared equals -2. Right. So we want to do the same thing that we did in the previous example, set it equal to 0. Right, 7y squared plus 3y squared equals -2. We just add 2 to both sides. It's a nice, easy step. Right, I'm also going to rewrite it. So it's 3y squared plus 7y plus 2 equals 0. Any questions there? Right, so now we're factoring. Notice that this is a trinomial. A does not equal 1. Right, so now we have to do 3 times 2 gives us 6. What's the product of 6? That gives us 7. Product of 6 that gives us 7 is what? Should be nice and easy.
6 and 1.
Very good. 6 and 1. And remember that from there, all we do is we break up the middle term. Now it's 1y, that's 6y, and we bring everything else down.
Okay, now I have a question.
Yes, ma'am.
When we did the first one, why we didn't say -3yx and 2yx? You know what I'm talking about? On A.
Let me go back. What was your question?
You saw you got the 1x squared minus x minus 6.
Correct.
And then when I'm not sure what that's called, what we did with the little table, and you rewrote it, you wrote x minus 3 instead of x minus 3x. Right? Or is that wrong?
Okay, you got to remember that this is a trinomial, and this is an example where A equals 1. So when you find your table, you just put them in. I mean, you just put those numbers in, right? Okay. So once again, I mean, that's why I'm saying that this is an easier one, because -3, you put -3. 2, you put 2. Trinomial, A equals 1, right? Really important to understand with A equals 1, these are very easy to factor.
Okay.
Right. But I want us to go back, right? This should be a nice, easy problem. But when we go to this problem here, this is a trinomial
where
A does not equal 1. You got to do it the long way.
Okay.
Right. So that's what makes that difference there. So I hope that helps understand that, Trina. Because when it's not 1, you have to turn it into a polynomial with 4 terms. You have to factor that. So does that help answer that question on why it's approached differently?
Yes, I get it.
Great. All right. So now, we do our factor by grouping here. All right. And we pull a GCF out now with the first 2, pull a GCF out of the second 2. Right. So GCF of the first 2 is a y. That comes out. And what are we left with?
3y plus 1.
Very good. 3y plus 1. What's the GCF for the next two? GCF here, y'all?
2.
2.
Very good. 2 comes out, leaving us with
3y plus 1.
very good. And now it's nice because we got two common binomials, right? So now all we have to do is write 3y plus 1. And then on the other one, we put y plus 2 equals 0. And now we can go ahead and solve for the first one, solve for the second one. All right, so you subtract 1, you get 3y to equal -1. And then we divide by 3, right? Giving us an answer there. Other one a little easier, subtract 2. Get an answer of -2. So answers are -1/3 and then -2. Any questions, y'all, with this example? Anyone need another minute copying this down?
Yes. Wait, I have a question. So, where'd you? Oh, I see it. You got those coefficients from the greatest GCF. I see it.
Okay, great. Are you still copying it down, William?
No, I'm done.
Okay. All right. Next example, C. 5b squared equals 10b. So we want to set this equal to 0. Right? So I'll subtract 10b to both sides. Leaving us with 5b squared minus 10b equals 0. Any questions there? So what factoring technique do we use here? All right, there should be a nice example because we're just doing GCF with this example here, right? Nothing more than GCF.
Do we do like the 5BB over 10B?
Yeah, we divide both of them by 5b, right? Because the 5b comes out, and what does that leave us with?
5b times b minus 2.
5b times b minus 2. Very good. All right. And then from there, now that it's in factored form and set equal to 0, now we can go ahead and set that to equal 0 and set that to equal 0. And then just solve each one of these. We divide this one by 5. We get beta equals 0. Here we should be able to add 2. Get an answer of 2, giving us answers of 0 and 2. Right, so this was factored by a different method. This was just factored by GCF. This is not even a trinomial, right? Nice example there. Any questions with that example?
I wish they were all that easy.
Yeah, well, I'll tell you that, they, especially I remember when, when Mr. Jones and I got together and we looked at these problems. I mean, we tried to make a lot of easy ones. We try to do a lot of problems where the factoring is very easy. So a lot of problems where the trinomial, where you have a trinomial and A is 1. Right? A lot of them. And then you'll see a lot of them just factored by GCF. A lot of difference of squares. Our whole goal is to get you to, if you can factor all these easy problems, then it's going to be an easy test for you. But if you can't factor an easy problem, then it's going to be a tough test for you, right? Because a problem like the first one, I mean, this should go by fast. Trinomial A is 1, like I said in red, that should be really easy. Where this second one, right? Trinomial A is now 1, that takes more time, right? You could definitely expect to see one of those on the test, but you're not going to see more than one on the test. Because if we do that, that takes away from doing other things. And as you'll notice in our lecture later today, y'all, you're going to be factoring a lot of stuff, right? So this is why if GCF is easy, difference of square is easy, trinomial with A is 1 is easy, test shouldn't be too bad. Right, so good comment there. All right, let's take a look at the next example. I think this one is also one that's a little bit on the simpler side. Y squared equals 64. Right, so we want to set this equal to 0. Right, so we just subtract 64 to both sides. Y squared minus 64 equals 0. And what are we doing here to factor this one out?
Difference of squares.
Very good, right? Difference of squares, right? Square root of y squared is y. Square root of 64 is 8. Should be nice and easy, right? Y plus 8, y minus 8, 0. From there, you should be able to get your answers. Right, minus 8, y is negative 8, plus 8, y is 8. So get these two answers. Any questions?